I'm Ankit, and today we'll be talking and learning about Pandas Library of Python. So, Pandas Library is mainly used for data analysis, data manipulations, and can be somewhat used for visualization and like doing some sorts of like works on data. And it can be used in a wide range of fields, including finance, economics, statistics, analytics. As I told you, analytics is like we could do data analysis with it, and it's a major toolkit in machine learning. So we'll start off with pandas data structures, and I'll quickly like my approach would be more of examples, more of practical knowledge than like and less of theoretical knowledge and less of theories and less of me talking, but more of me doing and solving practical uh, codes or practical examples. Okay, so first of all, I'll like briefly like go through the pandas data structure so that you can get a brief idea about what we are going to do and what we are like learning about. So first of all, the in the pandas there are three data structures. The first one being series, second one being data frame, and like this is the most important one. We'll be like using or will be learning or will be doing all sort of stuffs with data frames only. And the third one is panel. So we'll be talking very much like I'll just briefly explain you or briefly cover the series and panel, and then we'll delve into data frame only because that's what we are going to need. Okay, so as you can see in this table, I've like given the description, and this photo you can see in this image that the series is a one-dimensional, data frame is two-dimensional, and panel is three-dimensional. It's a way of structuring the data. It's a way of keeping the data. Okay, so series is one-dimensional and homogeneous array, as you can see in that table. Okay, and so what example I could take here is, here you can see that we can say as a series of a collection of integers, so 10, 23, 56, anything you can take. So this is homogeneous data, and that is all these integers or all these values are integers. Okay, so we can take a series of characters a b c d e f g, anything can have. So these are all homogeneous data. Okay, homogeneous array, that's why series is a homogeneous array. Okay, so next one is data frames. So this table, which you can like if you know about SQL, you will be familiar with this table or will be familiar with this data structure or type, or if you're not, then also it's fine because this is a spreadsheet kind of data. Okay, it includes rows and columns being verticals, like the name, age, gender, rating are all the four columns here, and the rows are these. Okay, so this is the first row, this is the second row, this is the third row, and that will be the fourth row. Okay, so from left to right or horizontal or the rows, and from top to bottom or the verticals are the columns. Okay, and so this is just a representation so that you can get an idea about what is how and what the data frame looks like. We'll be talking much more about data frames, but first I'll just wanted to like cover the basic things. Okay, and the panels one, we could not, like it's very hard to graphically represent it in this 2D screen. We are watching it in a 2D screen, so it's very much difficult to represent a 3D data or a 3D data structure in the 2D screen. So what we can like, how we can visualize it as is, we can like think of it as a collection or a stack of data frames. Okay, so suppose that data frames are stacked above one each other, so that's how we can visualize panels. Okay, so we won't be like needing anything, you won't be like needing anything, any information, more information about panels or series will be using in DataFrames only. Okay, so you just need a lot of practice and a lot of knowledge about DataFrames, and we'll be talking about that only. Okay, so before we talk about the Pandas library, okay, we will have to first import it. Okay, and we can just type import pandas, and as we don't want to, like, whenever we call pandas, write it as pandas, we can just call it as pd. Okay, just run this one. And okay, so if you haven't, like, I can show you the installation also. Okay, so for installation part, so pandas comes inbuilt, and whenever you install Python, you pandas is pre-built in, pre-installed in it. But just to make sure, we'll install it from the command prompt. Just go to the command prompt. Okay, and here you can just write pip install pandas, and it would be installed. And if it is already installed, it will show that the requirements is already satisfied. Okay, here you can see the requirements already satisfied. I'm getting this, so it's already in my computer. Okay, so this is just to make sure that we have the correct library, but we don't have to worry about it because we already have it in our computer pre-built whenever we install Python, as I said earlier. Okay, so we can close that. Okay, so now that the installation part is done, we can now, like, start off the pandas library and learn about it. So we'll first off create an empty data frame. We talked about and learned about data frames earlier, so we'll now try to create an empty data frame. Okay, so what we can do here is can create a variable named as df, and we can do pd here is pandas, we have assigned it as pd, so we are referring it here as pd. Okay, and what we can do here is pd.dataframe. Okay, this will create an empty data frame, and we are assigning to the variable df. Okay, so now what we can do here is check the result. Okay, so you can see here that this is an empty data frame. All right, now the next thing we can do here is, so we'll try to learn how we can create data frames from lists or texts and other things. Okay, so first off we'll start off from the lists, and then we'll move forward. Okay, so firstly we'll create a list. Okay, so first I'll create a list. We'll call it as data, and I'll type out some values. I'm giving us 1 2 3 4 5 4 5. So this is our list. Now what we can do here is the similar thing. I'm assigning the data frame to the df variable. Okay, now same pd dot data frame, and here I'll give the input as the list we have prepared. We'll name it as data, and I'm passing this as this to the pd dot data frame. Okay, so this will create it. Okay, so to visualize, I'm printing out df. Here you can see. Okay, so the bold ones here, 0 1 2 3 4 5 are the index. So 0 1 2 3 4 5 are index, and this 1 2 3 4 5 is the value that from the list that we have given. This is the column name 0. We have not assigned any column name, so it's been like 0 is the default value that is been given. Okay, now what we can do here is, okay, so let's try another example. Okay, and I'll again make a list, and I'll show you how to, like, give the names and stuffs to the columns and some values, and I'll show you. First we'll create a list, this being a nested list. I'll first column, my first column would be names, second column would be age. I'm typing first, my first entry is Alex, second one is the age of Alex, that is 10. I'm giving. I've closed the list. Now let's start another list. This is a nested list, of course. I'll type out the second name as Bob. I'm giving him an age of 14 years. And other one, let's try another one as Clark. And lastly, I'll give him an age of 12. Okay. Now this our nested list is prepared. Now what we can do is the same thing. Df equal to pd dot data frame. Alright, and what we can do here is pass the data, that is the list data, the name of the list. And now to assign the column names, what we can do here is columns equal to and the name of the list of one. So first one is name, that is Alex, Bob and Clark. The second column that I want is age, that is 10, 14 and 12. Alright, so this is how we assign the names of the columns of the data frame. Now we can do is print it df. You can write it as print df or simply df. If you want to see what happens when I write print df, I'll show you. Print df will give something like this, but since we are working in a like notebook environment, so if we just simply type df, we'll get a much better output like this one. Right, so here you can see the index again 012 starts from 010 and 012. Now we have given the name of the columns, first one being name, Alex, Bob, Clark, and the second one being age 10, 14 and 12. Alright, now what we can do is we can also what we can do here is change the type of the parameter. Here you can see the age is being in integer value. So what if we want to do, like, okay, I'll just copy this one. I don't want to write this again. Alright, so I'm just copying this and I'll make changes to this one. Alright, so here along with the first thing that the first parameter that I'm giving is data. That data is, or the data is the list of the name of the list. Here the list I'm giving. The second thing is columns name I'm giving. I'm assigning the name of the column. Now I want is data type, what I want the data types to be. So if I give data type, let's suppose data type of float. Okay, so what happens here is, let's try to visualize it. Look, this becomes the age column becomes float. So here we can typecast, like externally typecast the data types of the columns. Right, now let's try with like creating a data from dictionaries. Alright, so firstly we'll have to create a dictionary. Okay, so we'll create a dictionary. I'm calling it again as data. You can call it whatever you want. I'm gonna do the same thing. First thing I want is name. Okay, now what are the names gonna be? I want Tom, Jerry, and what to give Steve. Right, and can I give one more? Yeah, and last one I can give Charlie. So, Charlie. Right, now I'm giving the second key as age. The values will be the list of 28, 23, that's also fine, 28, 50, 17, 50, right, anything you want you can give. So this I've created a dictionary consisting of lists, also the values as lists, Okay, now what we can do is same thing. I'll assign it to again to df. The same thing we are doing, b.DataFrame, and here we'll give the dictionary data. All right, and if we want, like, if we simply give this like this, let's see what happens. All right, so if we give df here to see what happens, here you can see name, age. We don't have to assign the column names, it's already been assigned because we have given the key as name and key as age, right? So this is how we can create a data frame for dictionary. Also, I'll show you how to change the index. So let's let's try to change the index. I'll copy this thing. Okay, sorry, not this thing, this thing. Yeah, so df equal to bd.DataFrame. All right, now what we can do here is, along with the dictionary that we are passing, we can give the parameter index, right? Index we can give, and here we can specify what index we want. Let us give as a, b, c. All right, and one more thing, one more column, one more row is there too. So d. Now what we can do is print the df, and here you can see we have changed the index from 0, 1 to 3 to abcd. All right, so now the next thing we can do is, let's try, okay, I'll show you one more example so that you can understand it more clearly. So I'll create one more dictionary. Okay, now what we are here, we have a dictionary, and inside of that we have the lists. So here we can do is have a list, and inside we can have we can have a dictionary. Okay, so what we can do here is have the key value pairs as well. Here let's see, give a and have the value as 1. Now give b and have the value as 2. This is the one. Now for the column a, again we want the value 5, and column b, here the keys are the column names, right? And column b I want to give 10, and something like that you can do. And if, look, I'll show you one thing. I'll look what happens when I give one more value here. Okay, I'll show you and then you will understand it better. What happens if we give here a c, okay, c and a 20. All right, now let's try to df is equal to bd.DataFrame. First see the output, then you'll understand what I'm trying to do. Yeah, here you see this value here is nan value. What is nan value? That is not a number, or the value which is not been given, or which is not there, which is null value, we can say, is a nan value. So why here it is nan value? Because look, in this first row, the first row we are giving the a. The columns are, as I told you earlier, column names are a, b. But here in this row I have also created another column c, and I have passed the value as 20. I have given the value as 20, but in this row I have not even specified the column c. So what happens here, it will assign a nan value or null value. Okay, so this nan value is not a number and is appended in missing areas. Right, so you have to remember that. And we'll be like working on nan values later in this session. All right, so okay, now what we can do is, also let's try one more example. why not data equal to, and I'll show you how like the name NaN values. I'll show you one second. Maybe I should have the same, why not have the same data, right? And what I want here is, what I want to do here is, I'll show you in dictionary also you can do that. I'll show you data, first parameter, first we are giving the data. Now what we can do is change the index, and we can give it as first, we can give it as second. So you don't have to like give that give the index as 0 1 2 or ABC. You can like anything you want you can give. All right, I'm giving here as first second. All right, so that's what I was trying to show you, that you are not limited to like keep the index as 0 1 2 3 4 or anything like that, or ABCD or anything like that. You can give it whatever you wish to, but we generally prefer 0 1 2 3 4. All right, so now this was from dictionaries. Firstly we learned from lists. Yeah, from this is from, these are from lists. We learned from dictionaries. Now what we'll do is from series. All right, from dictionary of series. Now this one I'll have to type it, and I'll show you what happens in series. And the series is a like, here you can see what we have learned here. Series, you have in the earlier we talked about series and how we but we haven't talked about how to create a series. So we'll I'll briefly show you how to create a series and what happens, and how to create a series, and we'll use it in like mostly in making data frames. All right, so I'm using the series here to create a data frame, and I'll show you how it works. Right, so first I'll create the series. These are all the yeah that the process, or we can say the types, or the like different types in which you can create a data frame. All right, so you can use whatever you wish to, but these all options are present, and we can use any of it. All right, so I'm giving the column name as 1, and just like here we were passing. All right, here, which one was that, from dictionaries. Here, you can see here, first we were passing name. Here it was the column name, first column name as name. You can see it, name was the first column name, and then we were passing a list, which were the values of that column: Tom, Jerry, Steve, Charlie. Tom, Jerry, Steve, Charlie, these were the values, and we were passing it as list. Right, here we'll be giving us series, that is Pandas series. We have talked about Pandas series, and I'll show you how to create this. All right, and similarly for the second column, the key is the dictionary key is, second key is the name of the second column, age, and then we are passing the value as list of values we're passing. And in what we are going to do now is we'll have the same key, but we'll be passing the Pandas series, this series that I was talking about earlier. Okay, and we'll be using it to create a data frame. Right, so I've given the key name, that will be the name of our first column. Now pd.series I'm doing, and I'll create a series, and I'll show you how to do that. So pd.series, I now want some random values. I can give 1 2 3. Right, now we can also specify the index also here if you wish to. I'll give as 1, sorry, A, B, and C. Okay, this is how you create the Panda series. Right, this is, and I'll show you how it works when we visualize the output. Now let's give for the second column. Here we'll give for the second column. Right, let's go for second column. So, okay, yeah, 2. I'm writing the second column name as 2, and for the values of that column we are creating a series and passing out some random values for now. And index also let's give as A, B, C, and here we have given 4 values 1 2 3 4, so we'll have to give 4 indexes A B C D, right? If you want to know, if we don't give, first I'll show you, then I'll, okay, here we have to give df. You can type or you can give the name of variable whatever you want, but I'm giving df. And then sorry, this won't be df, all right, sorry, that's, you can give it data or d. Okay, let's give it data, and then we can create the df, and df will be pandas data frame. Same as before, we just have to create a dictionary, a list, or a dictionary of series, and then it's very simple to use the pd.data frame and convert it into data frame, right? Here, give data, you can go, you can see 1, and here you'll see the NaN values because we haven't passed the 4th value in this series, right? But in this series we have given 4 values, but in this we haven't, so we get the NaN value, right? Now if we don't pass this, let's see what happens if we don't pass the index. See, but we have given 4 values in this column, but for the index we have given only 3, A, B, C. Look what happens. Here you can see length of passed value is 4, index implies 3. So whatever the length of values you are giving, you have to give the same length of index if you are giving the name of the index, otherwise it will remain 0 1 2 3 4. Alright, so if you want, you can remove all of this. You can remove, okay, I'll show you in the next shell, right? I'll show you in the next cell. If you want, you can remove all this and remove all of this as well, all of this as well, and let's see what happens. Here you can see the index names are 0 1 2 3 only. All right, now what we can do now, these all were the ways of creating the data frames. Now what we will do is select specific columns or specific rows and like try to do some manipulation selections first, and then we'll try to do some manipulations as well. So, okay, so first we'll try to do is select a specific column. All right, so here we already have a data frame created, so I'll use this data frame only, right? So what if we want to select this column only, this column 1, this is the name of the column 1. So what if we want to select that column? What we can do is simply type df and this brackets, and we can type the name of the column that we want to select. Okay, if we do that, you can see 0 1 2 3. All right, these are the index, this is the index, right? And these are the values of that column. And here you can also see the data type here is float. Now if we want to add another column, what if we want to add another column? Let's say here is column 1, column 2, and let's have a column 3 as well. So what we can do is you can type whatever name you want to give the column. You can type it as df given the quotes and in the square braces, and here I have given the name of the third column that I want as 3. So you can df3, and what we can do is pd.series, just like in the creation of data frame we can pass it here as well. So pd.series, alright, and here you can give the values that I want, 10 20 30. If we give another value, if we don't give another value, we'll get a NaN. So let's have the NaN. Let's see, and index I don't want to give. Let's not give the index. Okay, so let's not give the index. Now if we do that, and when we run this, when we print the result, the df data frame, here you can see the third column has been created, and this is the name that we wanted, we have assigned, and these were the values 10, 20, 30. All right, and we have not given, since there were 4 rows and we have not given the fourth value, this we get as man. All right, now what if, like, let's do some manipulation, right? Okay, so what we can do is adding the content of columns, right, in a new column. All right, let's create a new column and add all these values, and the result will be in the new column, right? You get my point? So let's create the new column. We'll name it as 4 or added values. Let's give it as added, right? Df added, and then we can do is df1 plus df2, right? And what we can do is df, so 3. It's important that you type the correct name of the columns, right? Now what we can see, we can do is print the df, and here you can see we have created a column called as added, and we have added the column, the values in the columns 1, in the values in the column 2, and values in the column 3. So 1 1 1 plus 1 2 plus 10 12, 2 plus 2 4 plus 24, and similarly, right? Now let's try to delete a column. So how we can delete a column? So we can use using delete function, del function. All right, we also have a pop function. First we'll try with del function. So simply we can give del, and whatever column we want, we can select that column. Del of, let's try to delete the first column. Delete df and select the column. Delete and give the column name, that is the select the column first, or whatever column you want. So I've selected this one, and that will delete the first column from the data frame, right? So now what we can do is we'll print the df, and you can see the first column has been deleted. The one column, the first column has been deleted. The column named 1 has been deleted, right? Also, let's try to use pop function using deleting using pop function. Okay, so it's same as delete function. Here you just have to df dot pop, and let's try to delete the column name 2. So this will delete this column, right? So what we can do is give this, and to see the result, what we can do is see df, and the 1 and that is 2 is been deleted, 1 has been already deleted, so all I have left is 3 and added columns. So this is how you can delete a column, right? Now we are working with columns. Now let's work with some rows, and how we can work with rows. We can work with rows with two types, like there are two log function and ilog function, so we'll learn both of them. All right, so let's select the rows, selection of rows, selection by labels or the, you can see as log function. Selection by labels, if we want, we'll use the log function, and the next one will be selection by integer locations, and we'll be using the ilog function. All right, so first we'll do the log function, then we'll do the ilog. So let's first create a data frame. I already have a data frame. Let's see if we have a data frame. I don't want to create another one. Yeah, use this one. This has some labels as well. Yeah, let us use this one. This is the data frame that we want. Okay, so the column name first is 1. Okay, let's try to first show you how the data frame looks. vd dot data frame will first create the data frame, and let's see how it looks. Yeah, so this is our data frame that we'll be working on. All right, now how we can select it. So we are selecting a row, right? And these are the labels, the indexes. Here we have given the names, right? It is A, B, C, D. So these will act as labels, right? So we can select any row. Like if we want to select this row, so this has a level of B. These are the column names, and this has a level B. So this, if we want to select this row, we can select by the label B, right? So what we can do is df.log. Here we are, as you can see, if we want to select by labels, we need log function, loc function. So df.log, and here we can see B. We want to select the bth row, right? So here we can see the column 1 has 2.0, column 2 has 2.0, right? If we want, we can also do select column C, df.log C, and we have the 3s, right? So this is how you use the labels to select the rows, right? Now let's try by integer location. Let's try using the ilog functions. So I'll just comment this selection of, or selection by integer locations, and we'll be using the ilog function here. Okay, now what we can do is, if we want to like select which column, which row, let's try to select this row, right? So what will be the index of this row? So this will be 0, 1, 2. So this will be the second row. This will be the 0th row. This will be the first row. This will be the second row. So if you want to select this one, we'll use df.ilog and we'll pass 2 here, right? This will give us that row. So I'll repeat it once again. This is the 0th row, this is the first row, this is the second row, this is the third row. 0, 1, 2, 3. Index value starts with 0, that's why. So df.ilog2, so that will be 0, 1, 2, and that row will be selected. Alright, so we can have then, and we can do anything we want. We can do any manipulations, etc. to that row. So now what if we want to, let's show you how to select multiple rows, alright? And we call this as slicing, selecting multiple or I could just type multiple rows can be selected using the colon operator. This colon operator. We'll learn how to use the colon operator. This is very important. Okay. Now let us suppose we want to select, here is the data frame there. So let us suppose we want to select the these two columns, the cth column, the dth column. sorry, why am I saying columns? The rows. All right. So let us suppose we want to select the cth row and dth row, right? So what's the index of this row? So 0, 1, 2, and this has the index of 3. So 0, 1, 2, 3. So we want to select index 2 and index 3. What we can do is use the slicing operator, right? So how we'll use the slicing operator? So the first value that we'll give is 2, all right, and then we'll use the colon operator, right? And look, I'll have to so the second value that we have to give, this is the, okay, first I'll show you how to do that and then I'll explain. Look, this will select this one. Okay, so now how this works. So this is the starting index that we want to select. 0, 1, 2. We want to select these two, C and D, these two. So what is the starting index? 0, 1, 2. So we want to select these. So this is the starting index. 2 is the starting index. So we have given the starting index. Okay. Now we have to give the ending index plus 1. All right. So what this does is it selects up to -1. So if we give 3, it will only give like 0, 1, 2, 3, right? We don't have any index 4. We don't have index 4 in this data frame. 0, 1, 2, 3. Fourth index is not present, but still we are giving here is 4 because the second argument, the second value is -1, or we can say is it will select the rows before this one, before the fourth index. So if we want to select up to third, we'll give 4. All right. So to select second index and or index 2 and index 3 up to index 3, we'll give 4. Okay, so this might be a bit confusing, but I'll explain with another example. Now let us try to select B and C. Let's try to select B and C row, right? So what is the index of the start? What is the starting index? What is so the first value that we have to give here is, let's first put the colon operator, and in the left side of the colon operator we have to give the starting index from where we want to select. So the what is the starting index? If we want to select B and C, what is the starting index? So 0, 1. 1 is the starting index, so I'll give 1. Okay. Now what is the that is what we have from where from up to where we have to select? We want to select B and C. So what is the index of the last row we want to select? So 0, 1, 2. 2 is the index, so we'll give 3. Why? Because this as I told you before, this argument that is after the column, the right side of the column, we need to give the index or the value which will select before that. All right. So if we want to select on up to index 2, we'll give index 3. If we want to select up to index 3, we'll give 4. We have to select up to index 1, we'll give 2. So we give it as +1, right? So you just have to remember that or keep in mind. So this is how now we can check if we have correctly sliced the data frame. So yes, we have. So we have selected B and C. Okay, so I'll explain what. So let's try to select A, B and C. A, B and C. So what is the starting index? That is 0. The ending index +1. So ending index is 0, 1, 2. To ABC I want 2 is the ending index. So I'll give as 2 plus 1, 3. So 0, 2. So this is how we select the 0 A, B and C, or 0th index, first index and third index, right? And now what we can do now is, okay, so what we can do now is Alright, I'll show you how to append also. Before going into handling missing data, so I'll show you one last thing. That is to append two data frames. Let's create a different data frame. I'll call it as df2. So I'll just quickly make this data frame df2 equal to pd.dataFrame. We can give some random values. I'll show you how to like add rows, right? To add the rows, we can do is like this is the data frame that we're working on. We want to add some rows. Suppose we want to have rows E and F. So how we can achieve that? I'm trying to show you, right? So I'll comment that also. Adding rows by appending data frames, right? So df2 equal to pd.dataFrame. Now here what we can do is have some values of the rows that we want to append, 5, 6 and 7, 8. So this format is I'm giving 5 to the 1 column, 6 to the 2 column, and 7 to the 1 column, 8 to the 2 column, right? And I also want to give the names of the index. Since we have ABCD here, I'll give EF here. So let's give the index as EF. Let's have the index. Okay, so one more thing that we have to specify, we are creating a new data frame here, right? So firstly we will need to have the columns also having the same name as the previous data frame. So I'll give the column names as 1 and 2. Okay, so this is the same as the previous data frame here, 1 and 2, because we want to append this data frame into that data frame so that we can have 2 more rows. So here we are creating a data frame of 2 rows, and we'll try to append this data frame df2 into the df data frame, right? So you get the idea what I'm trying to do. So we'll have to have the same column names. That's why we are giving the same column names. Now index we can give as E and F. So index in the list E and F. Okay, and that is it, I guess. Yeah. And then if you want to see how it looks, okay, I'll show you how it looks. df2, this is how it looks, having index E and F, having values 5 in 5 and 6. Here how it is being given is 5 to 1, 6 to 2, 7 to 1, 8 to 2, right? Now what we want to do is add these 2 rows in this data frame. This is our original data frame. I want to add E and F rows to that data frame. So how we can achieve that is we can use the append function, right? So let's try to append it. We want to save it in df dot append and df2. We want to append it in df, that's why we are giving us df dot append, not df2 dot append, right? So we want to append it in df, so that's why we are giving us df2. Now to see the result, we can print df. Here you can see we already had A, B, C, D rows. Now we also have EF rows because we have appended this df2 data frame into this df data frame, right? So this is how you can add more rows to the data frame by appending other data frames, right? Now we'll try to, what we'll do is handle some missing data. If what happens if we have some missing data, then how we'll handle it or how we'll approach it, we'll talk about it now. So first we'll need a data frame. So let's try to have a data frame, right? Create a data frame. Now what we I'm trying to create a dictionary, and from that I'll create the data frame, right? So I want the first column name to be first score, then I'll give the values as 100, 90. Let's give the, now we want some missing values in this data frame, so we'll have to give the, since we are the one creating this data frame, so let's give some missing values so that we can work, so that if we come across any missing values, then we know how to deal with it, or you know how to deal with it, right? So let's give missing values. We can give nan values. To give nan, and to give nan values, we need to have np. Np is numpy, and we need numpy, so we need to import numpy. So np.nan is the nan values. To have some nan values in the data frame, we'll use np.nan. This will have a nan values or null values in that cell, or in that it will have a null value. All right, so we can give the last as 95. This is the values that I want in the first column. Let's create a second column, and we can name it as second score. Then we can give the values as anything. Okay, so we can give the values 30, 45, 56, and let's have a nan value. Okay, and we can have one more column. Let's have one more column. Okay, I forgot to, oh no, I have given the commas. Yeah, and let's have the third score. Let's have the third column named as third score, and the values will be, let's give the nan value here, 40, 50, 80, and 98, right? So this is our dictionary. I won't be giving any index and all, like, okay, so so I don't want to give any index, and data frame, and here data, so I won't be giving any index and all. I'll be keeping the 0, 1, 2, 3. Now let's see the data frame. So this is the data frame. Wait, what have we done? Okay, sorry, not data, here should be dictionary. We have given us dic. Okay, let's name it as something different. Let's name it as, okay, all right, data only. Data only I'll give. Okay, I'm getting some error. Let's see what's the error is. Or array must be all same then. Okay, so what I have done is, somewhere I must have given different errors. Yeah, here I've given 5 values: np.nan1, 42, 53, 84, and 98, 5. Right, so let's remove one value. Let's remove 98. Now it should work. Yeah, it works. So this is how you read an error and correct your codes. So you must know how to do that as well, because we are not perfect, and you need to know how to, like, resolve your errors. And if you don't know how to resolve your errors, check in Google Stack Overflows. Like, you somehow have to, like, get whatever you want, or get the actual desired output. Alright, so now we have the data frame created. Now what we have to look in this data frame, we have how many nan values. We have nan values here, nan values here, nan values here. And now what is nan values? So null values, or the values which are not there, or the empty values, null values, whatever you want to say. So there are no values given to that. Here it has no values, nan values, nan values, nan values, right? So now we'll see if we come across any data set or any data or anything, any spreadsheet or anything that has some nan values, then how we'll deal with it, I'll try to show you. And it's a very important thing in your machine learning toolkit, right? So firstly, what we'll do is, if there are a lot of data, like if there are thousands of rows and thousands of columns, you can't by yourself or manually see, okay, what are the nan values, or if it contains nan values or not. So what we can do is check if it has nan values or not. So let's see if it has nan values or not. So what we can do is using is null function. So we'll be using is null function to check if the data frame here df is having null values or nan values or not. So what you can see is the values which are null will be true, and the values or the correct values or which has values will be false. So 100 is false, 30 is false, and true is given to nan because that is nan value or null value. Similarly, this is true, and that is three values are nan, so there are three truths here, right? So this is how you can see if there are any nan values in the data frame or not. So this is a good way to see it. Now what we will do here is how to deal with the nan values. Here we have identified if the computer or if the data set have null values or not. Now what we want to do is do something about the nan values. So what we can do is we can try to fill the nan values with some values, or we can delete the rows which are having null values. So we'll try to do lot of stuffs with it, right? So first what we can do is give a custom value to the nan values, right? So let's see what we can do. Let's use I'll be using fill na function to do that. So I'll show you what fill na function does is filling missing values. How it using fill na function, right? So fill na. Now what is it? This is our data set, right? So in the nan values, what if we want to have let's try to give zeros. What if we don't want nan values here, and we want to give all the nan values as zero, like we want to replace all the values here to be zero. So all the nan values, all the nan values to be zero. So what we can do is we can fill them with fill na with zero. That is fill na means null values to with 0, or you can give any value. I'm giving 0. If you want to give 100, then all the nan values will be 100. So if you give 0, what happens here is, see, all the nan values, this was the nan value, this was also nan value, this was also nan value, all this has been given as 0. All right, but here, okay, but this does not change the data frame. Okay, if you will print the data frame now, it will still have nan values. All right, so if you want to make the changes permanently, you can either do df equal to df, you are assigning, since this will assign it to df, so that will make the change permanent. You can do this that is df 0, and what this will do is it will make this permanent. Now if you will check df, it will be 0, so this becomes permanent. So if you don't want to or there is another way you can do is okay, first now that I've made it permanent, I want the nan values back, so I'll run that code again. I want the nan values back, so I'll run that code again. Okay, so now we can check again, it will have nan values. Yeah, now other way to make the changes permanently is, what we can do is, let's see if it works or not. df.fill na if you want to give, let's give 50 this time. Let's fill the NaN values with 50 in this time. Let's see if in place works here or not. Place equal to true. Yeah, it works. So if now if you'll see it here also, the changes will be permanent. Here in place equal to true, by giving this parameter you are like making the change permanent, right? So now this the NA values, this NA values have been given 50, 50, 50, 50, right? So this is how we can fill the missing values by a custom number whichever you want. Okay, now that we have made this change permanent, I want the NaN values back so that we can do more stuffs with it. So let's run it again to have the NaN values back. And here to have the NaN values back. Yeah, you can see NaN values are back. Now what we will do is, now what we can do is, yeah, there is another like attribute, we can say a parameter we could say of NA, fill NA, that is we can fill the values with the previous ones. Suppose this value, we can give the previous value to it, that is 90. Okay, so in some cases if we want that, we don't want any custom values and we want the value which is before it, that is if this value is 90, I also want the NaN values to be 90, or if this value is 56, I also want that value to be 90. Since this doesn't have any previous value, so this will remain the same. So let's try it and see how it works. Okay, so I can comment that what I'm trying to do, I'm trying to fill null values with the previous ones, right? Previous ones. Okay, I think you can understand with that statement. Okay, so df dot fill NA, and here we'll do is use the method equal to pad, right? So what this will do is, as I told you earlier, okay, I have given it as fill NA, it should be fill NA. Yeah, let's see the result. So you can see this NA value has been assigned 90 because the previous value to it was 90 as well. This NA value has been assigned 56 because the previous value was 56. This is unchanged because it doesn't has any previous value, so this remains NaN value. Okay, now let us try to, now what if we want the next values? There is also a method for next value, that is bfill. So we can comment that also, fill null values with next value. So what we can do here is method equal to, and for this I said you have to use bfill, right? And what will this do is have the NaN values will be the value after that. So here it was NaN, so what is the value after that? That is 95. So this NaN value will also become 95. Since this NaN value doesn't have any after values, or it does no values is after this value, so this will remain unaffected, and this value has 40 after it, so this will also become 40. You can see here 40, this remains unchanged, and this becomes 95, right? So this is how we can fill the values with the next values. So these are all the types, these are the methods you can do. Also we can also like it's not compulsory to give like numbers or integers, we can also give strings. So let's have, first of all, let's have a column of categorical data. Categorical data means data which contains strings. Okay, categorical. So let's first we'll create a new column categorical column or new column having strings. So what I'll do is have a column name, let's take gender. Okay, and what we can do is pd.series. I can do, and I'm trying to add a column. I've already told you we already know how to add a column here. We can see here. Okay, just to remind you, adding a column. Yeah, see here we have already added up. Okay, not here, like this we have added, like this we have added, so I'm using this method. Okay, so I'm adding a column named gender, and I'll pass some values, male and female. Okay, let's give, and also I'll give a nan values in between these values. So first I'll give a male, give a female, let's have a nan values, right? Let's give another values as female. Okay, now we are creating another column. Let's see the column, let's see the data frame. I mean, yeah, we have created another column, male, female, nan value and female, right? Now how to work with this? So what we can do is we can fill NA and give some values to, like we can also pass some string to the all the NAs, right? What we can do is, like we can do what here is df.fill NA, and we can pass the string. So df dot yeah, right, like this we can. Before, earlier we were giving yeah, 50 or 0, these values we are giving, but we can also pass string. So what will happen is, look what happens, all these, yeah, all these will nan values will become no gender, no gender, no gender, but we only want to have no gender in this one. That with no gender doesn't make sense here, right? First score and value having no gender doesn't make sense, obviously. So we only want this to apply in the gender column. So what we can do is df dot, or we can do is df, we can select the column which we want to apply. Here we are applying it to all the like the whole data frame df. So what we can do, look here, we are applying this fill NA function or method to whole df. Now we can do is select the gender column and apply it to that, right? So this is how we can do that, and here we can give no gender, and yeah, what will happen here is this. Okay, so if you want to see it in better format, let's try to make the change permanent. Let's give in place equal to true, so that we can visualize it. Okay, now we can df. Here you can see it is already only being applied in gender column, because we have selected that this function can should like this should work only for this selection of column, that is the gender column, right? So this is how we can, like treat the null values and like fill the null values with either in strings or in numbers. Like we can give zeros and all, we can give hundreds or anything, any custom values, or if we have a column of strings, we can pass like this. If like no gender, everything we can, like anything we can pass, right? So this is what I was. Now the next one, there is also a method that is replace method. We can also use that, very similar to this fill array, but let's try that also. So we can do is df dot replace we are working with this dataset only, and here we have to pass to replace. So what we want to replace, we want to replace nan values, np.nan, and what, by what we want to replace, you can give value equal to, let's replace it with 10. So all these nan values will go to 10. Okay, so this is how it works. So we have to give what we want to replace, that is nan values, np.nan, and what we with what we want to replace it. So I'm giving the value equal to 10. Okay, so this is how the replace method works. You can see nan values has been replaced with the value 10. Okay, now these were all the methods like to fill the value, right? Now what if we want to drop the rows which have nan values? Look, this row has nan value. Okay, this row has, okay, so first, if you are thinking that this is permanent, then it is not. Of course, like the fill and it is not permanent, but if you want to make it permanent, you can just write in place equal to true, and this will be permanent. But right now it is not permanent, so if you df or print the df, it will be like nan, like this. Okay, so we are working with this data set only. Now here you can see the first row has nan value, the second row doesn't have any nan value, the third row has a nan value here, and the fourth row has a nan value. So what if we want to, like, if in some case we don't want to fill any value to it, or give any custom value to it, and we just want to delete that row, like we want to get rid of that row, like we don't want this row, we don't want this row, we don't want this row, and we only want this row, or similar things, that we, if any like column, or if any row has any nan values, we can just simply remove it. So what if we want to do that? So we can use the drop any method. So what we can do is dropping missing values using drop any. Right, now what we are trying to do here is dropping rows, as I told you, dropping rows having nan values. So what this will do is df dot drop na. We just have to give this, right? Now if I run this, you can see we are only left with this row, because this is the only row which doesn't have any nan value. All the other rows have nan values, so they have been dropped, right? So if like this will lead to some like loss of data, so we avoid using it. But if in case, or in some cases, you just need to get rid of those rows which have nan values, you can just use the df dot drop na or drop na method of function, right? So this is how you can treat with the missing value. So these are all the ways you can replace it, you can fill with different values, you can drop it. So these were all the operations or the methods, or how you can deal with the missing values, right? Okay, so that's it for today's session. We'll wrap it up now, and we'll continue in the next session tomorrow. That's it from my side today.